Okay, just a quick follow-up, give one more example over Lewis dot structures. And so want to make sure we have an idea of the four steps for things we do when we set these up. So let's get an example going here, and we're going to do NO2 plus 1. Okay, so that's what we're going to do. So first step one, is you need to find the central atom and you're going to attach all the pieces to that central atom. So you're going to find the central atom and attach the other elements. Remember, we have a middle and everything attaches to that. Now, there are some exceptions, but this is for most of what we do. Okay, number two, we're going to add what we call lone pairs. And lone pairs are just electrons like that. So we add lone pairs to create octets. So what is an octet? An octet is just the magic number 8. So we're looking for 8s. Okay, so everything gets 8 except hydrogen. Remember, hydrogen is okay with 2. Hydrogen's a pain. Number 3, we're going to find a target number. And how do you find a target number? You count you count valence electrons. Okay, that's how you find a target number. And then number 4 is a little more complicated. I can't really write it all here, but you're going to compare the target number to how many electrons you have. All right, so that's where we add the double, triple bonds, that kind of thing. So, okay, step 1, central atoms. So let's use a different color, and I think I'm going to erase my NO2 plus and slide it over here. NO2 plus. So central atom is the first one, unless it's hydrogen, or unless they've told you something differently. So put the N in the middle. O, see the N's in the middle, and everything else is attached to it. So it's find the central atom and attach the other elements. We have done that. Boom, got that done. All right. Step 2, add lone pairs to create octets. So remember that every one of these has this little imaginary box around it. It has a top, a right, a bottom, and a left. You need to make sure that there is something in each of those spots. If you don't have something in one of those spots, you add a pair of dots. So I'm going to go ahead and do that with my nitrogen. So I'd go pair here, and so now every side of the box has an attachment, either has a bond or a set of lone pairs. Okay, done. That one's done. Find a target number. Okay, let's find a target number. We got N and we got O. So let's go over here and look. I've already highlighted them. Okay, here's O. Oops, don't want to do that. Here's the O. It has 6. And here's the N, it has 5. So it's based upon the column that they're in, right? So based upon the column. So the N gives us 5, and the O gives us 6. Okay, so we're going to remember that. Okay, so here we go. What did we say? We said the N equals 5. And we said the O equals 6. Problem is there's 2 O's, so that's times 2. So you basically have 5 plus 12, which is 17. But wait, there is a plus 1. So does that mean you get an extra electron or you lost one? Well, it actually means you lost one. So you do the opposite. So we'll subtract 1. So our target number is going to be 16. So this is the target number. All right. So now we're gonna do compare. We've done 3. Now we're gonna compare the target number to the electrons, and then we'll make some changes if we have to. So I'm gonna circle these. Everything counts as 2. Okay, so everything counts as 2. We're looking at this target number here. Everything counts as 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We have 20, but we're only allowed to have 16. We have too many, so we got to fix it. Okay, so what you get to do is you get to add a bond and take away a set of electrons from each side of the bond. So I'm going to put a bond here. I'm going to get rid of this pair and this pair. Okay, now we count again. We're still trying to get to 16. We count again. You're going to get 18. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So remember that we have some that are now gone. So if I count 2, 4, 6, 8, 10, 12, 14, 16, 18, that still doesn't work. 18 is not 16, so it still doesn't work. So I've got to do it again. You could put a triple bond here and get rid of 2 pairs, or you can put a double bond on the other side and get rid of 2 pairs. It doesn't matter. I think I'll go with the 2 double bonds. It does not matter, so take away a pair from each side. If you count now, we're going to have 16. So let's count again. 2, 4, 6, 8, 10, 12, 14, 16. Boom. We've got it. That's the answer. So what we have matches the target number. So I usually rewrite it just to clean it up a little bit. So there's my O, there's my double bond, there's my N, there's my double bond, there's my O. The N doesn't have any dots. This O has 4. And you can just kind of make sure they're on there. I kind of like to make them look symmetrical, but you might want to leave them. It might be better for you to leave them in that original position. That might be a little confusing for you. So this is probably better for you guys. And there's one thing that we have to remember. If it has a charge, you finish the structure by putting a bracket around it and putting the charge on the outside. So that is the completed structure. Everybody has 8, goes to 16, not a big deal. Now what happens if you don't have a central atom? Like you got something like this, or something like this. Well, sometimes you just don't have a central atom. And so H2, you would just connect them both. That's the best you can do. And then C2H6, you actually have 2 central atoms. And so you just make it symmetrical, kind of like this. Now, these are things I don't think are going to come up a lot, but they're just, sometimes you don't have a middle, or you have 2 middles. So once again, our rules don't work for everything, but if you follow these steps, find a central atom. Find a central atom, add lone pairs to get the 8s. Check your target number, compare your target number. You're going to be okay.